Bismillahirrahmanirrahim. Assalamu alaikum, everyone. I offer my warm welcome to all members across the globe and who have registered for this webinar. And we have also shared the link of this webinar on Society of Chemical Engineers Facebook page. In case anyone is facing problem in joining the Zoom, they can directly watch this presentation on the Facebook as well. This is the facilitation to all. And let me explain a little bit. Society of Chemical Engineers has been developed by senior professionals who are working in the industry, and they have a rich experience, maybe more than 2 decades, 3 decades experience in their field, in especially design, engineering, operation, and maintenance. They are serving the various industrial sector like oil and gas, petrochemical, chemical, power, fertilizer. The objective of this society is that in Pakistan, there is no active society which is contributing toward the industrial sector. Although the name of the society is the Society of Chemical Engineers, but our motto is to bring the engineers or professionals who are working in the industry. They should come and join and shake hands and share their knowledges among each other. Apart from the territorial restriction that we are Pakistanis or we are working in Gulf, Canada, America, Europe, all engineers, our objective shall remain that all engineers should come up front and they should share their technical knowledge with the upcoming professionals, especially youngsters. And secondly, they should also develop their soft skills, their management skills, computer skills, and the Primavera and other software which we have. We can educate our professionals free of cost. And we have the different segments, and this is our third webinar which we are offering. And fortunately, Mr. Muhammad Fiaz, who is a chemical engineer by profession, he was very passionate to come and deliver the basic knowledge on the fundamental of oil and gas production. We have the participants from USA, UK, Canada, Finland, Zimbabwe, Nigeria, Tanzania, Malaysia, and UAE, Kingdom of Saudi Arabia, and Pakistan. It's really very encouraging that all the professionals across the globe, either they are Pakistanis or belongs to other countries, they are participating and they are representing their country. It's a very good sign that we can share knowledge with each other across the globe, and the professionalism should prevail. Any professional who is willing to deliver some technical knowledge or dissipate some knowledge to the engineering community, he is most welcome. He can contact us and we will surely provide him the opportunity to share his knowledge and expertise with the other professionals who are trying to grow in respective fields. We have also created a WhatsApp group for the person who have registered for this, who have the registration for this webinar, so that we can keep on posting them various webinars which we conduct. They will get the direct information. Today in the evening, after 4 or 5 hours, we will not allow anyone to contribute or send messages in the group. Only the admin can send, and they will only inform you about the upcoming events. And so that if you are willing, you can join. You are now registered with Society of Chemical Engineers, and you will directly get all the information about our upcoming events. And secondly, this presentation will also be uploaded on the YouTube, and on the, you can see, I will share the link of the YouTube. Once we upload this presentation, you can also watch at your convenient time again if required. And secondly, one thing more, if you require any specific presentation, you can inform us in the group today that this is the area where you require some training so that we can compile those preferred titles and we can manage to deliver you the proper presentation for the improving technical skills. And now I will introduce you with Mr. Fiaz. Mr. Fiaz is a chemical engineer by profession and from UET, University of Engineering and Technology, Lahore. He has a 33 years diversified experience in the engineering and the technical operations. He has published many articles on the process design and on the technical aspects of oil and gas industries. He has worked with world-renowned companies. The chemical engineers do know that what are the world-renowned companies in oil and gas, and that is ZETCO, which belongs to ADNOC, then the Flo Daniel, Foster Wheeler, Descon Engineering, and presently he is working with the Dragon Oil as operation and engineering head. Now I request Fiaz Saab to just take over this webinar and start your presentation after giving a little more introduction about you. Thank you very much, Fiaz Saab. You are welcome to start your presentation.
Assalamu alaikum and good afternoon. Let me introduce briefly about myself. I am a graduate engineer, as Mr. Malik also introduced, and I have worked mostly in oil and gas production. So the objective of today's webinar is to share the knowledge about oil and gas production processing facilities. In oil and gas production, there are three areas. One is called the subsurface or reservoir engineering, or reservoir, which is very deep in the underground. And then second area is called drilling, which you drill a well to bring the oil from the reservoir to the surface. Once the oil reaches to the surface on the wellhead, then from onward, it is called production facilities for oil and gas production. My today's presentation will cover the third part. That means the oil is already, reservoir is established, drilling has completed, and the oil reached on the surface. When oil reach on the wellhead tower, from that point onward, we process the oil to make it ready for sale to go to the refineries for further processing. Just for information for all of us, when crude oil has oil, gas, water, sand, salt, asphaltene, sulfur compounds. So all these impurities have to be removed to make the crude oil ready to go to the refinery. So my today's session is covering the sweet crude handling. Let me explain what is sweet and sour. If crude oil is having H2S or any sulfur compound, it is called sour crude. And if there is no H2S or sulfur compounds, we call as a sweet crude. So my today's briefing will be about sweet crude production from wellhead platform till the storage tank. Okay. Bismillahirrahmanirrahim. This webinar is being attended across the globe from UAE, Saudi Arabia, Tanzania, Malaysia, Canada, Pakistan, Finland, USA, Zimbabwe, UK, and Nigeria. So thank you very much for attending and sparing your time to get the briefing on oil and gas production fundamentals. This is a basic pictorial of crude oil and gas. Here in this, you have a curve on the top and the curve on the bottom. This is called, you can say this is a isolation zone. So the crude oil along with gas is trapped between these two layers naturally in the ground, few kilometers subsurface in the earth. Sometimes it is 700 or 500 meter to maybe about 3 to 4 kilometer deep. And the oil, we drill the well, and then the oil will come on the surface, and then we process the oil to make it ready to go to the refinery. Mostly the hydrocarbons, which is called oil gas, there's a gas, there's a liquid, and there's a solid. Up till 4 carbon items like methane, ethane, propane, and butane. These are naturally occurring gases. So when we drill a well and the crude oil, the word crude oil means oil, gas, and water and solids. All gases are up till C4. Just for information, this liquefied LPG is called propane. This is the definition of that one. From 20 onward, it is called liquid, and above 20, it is solids like asphaltene or coal tar. Just quickly, I will let you know the composition of the oil and the gas. It's worth to note here in this slide that methane C1 is 95% on the gas phase, and C7, which is the heaviest component, is 42% in the black oil. So all the lighter ends remain in the gaseous phase, all the higher components remain in the liquid phase. And the natural gas, we have methane, and in the gas, C1 is about more than 90%. Then we have ethane, propane, butane, then traces of pentane and hexane. This is the composition of the gas. In our crude oil, we have traces of nitrogen, CO2, and H2S. When we process the crude oil on the surface facilities, we have to get rid of all these impurities and the gases to make the crude oil ready to go to the refinery. In oil and gas industry, we have a very unique terminology. The first terminology which we are using is called crude oil. There's no fine oil, everything is crude. So crude oil is a complex mixture of hydrocarbon produced from the reservoir in the liquid form. And then we have natural gas, which is associated with the oil accumulation as a free gas or dissolved gases. Then we have two terminology we are using with respect to gas. One is called free gas, other is called dissolved gases. Free gases, when we drill the well and the liquid come on the surface, it is available in the form of free gas. The dissolved gases remain in the liquid, which we have to process by heating so that the gas will be liberated from the oil. That gas is called dissolved gas. This is unique terminology we are using in oil industry called produced water. This is a different from the normal water. This is also the life of this water is same as the crude oil. Maybe millions of years, this water has remained with the hydrocarbon. And when it comes on the surface, it is called produced water. One thing you have to notice that this produced water, the salinity of this produced water is much higher than the seawater. In Indian Ocean, assume we have salinity of Indian Ocean water is like 25,000 ppm. The produced water coming from the neighboring field is having about 45 to 55,000 ppm of salt. So it's a very salty water, and it has to be separated out before we send the crude oil to the refinery. This diagram is very important, and to have this one. I will start this one. This is the whole production cycle of crude oil. We have a reservoir on the left side of this slide, and we drill the well. This black line, you can imagine this is a well, and the well will reach to the Christmas tree. Here is the Christmas tree. In oil industry, the first unit operation is called separation. It could be two-phase separation, it could be three-phase separation, but in every field, everywhere in the world, we have to separate the different phases of the crude oil, like water, gas, and solids. So when we do the two-phase separation, gas will go from the top and the liquid, and this liquid is having oil and water both. This total liquid will go to another separator, which is, we can call this one as a three-phase separator. So we will get rid of the produced water. So up till here, you get the gas out from the crude oil and produce water separated from the three-phase separator. But this crude oil is still not ready for sale. Still some water is in the crude oil and some salt is there. So we have to dehydrate the water. We call this process we call dehydration. And then after the dehydration, we wash the crude. We call this process in the industry called desalting. So once we get rid of gas, water, and salt, the crude is ready to go to the crude oil storage tanks. And from this storage tank, it goes to the refineries. This is a typical schematic of offshore processing. The left side here is the wellhead tower, or wellhead, you can call it wellhead. It's a very interesting thing. In this wellhead on the top, we have two wells drilled from the same conductor. This is a separate engineering called drilling. So when the oil reach on the surface here on this arrow where my cursor is there, we go to the high pressure separator, and then we go for subsequent processing by hot oil heaters and this type of unit operation. There is one vessel here, a test separator. We in industry go on testing the well, what is the production potential of the well. Based on the data received from test separator, over reservoir engineers and well operation engineers, they will take the clue from the testing what they have to do in the well. Over this, today's presentation is downstream of the choke wall, from this point of the choke wall all the way to the storage tank. Briefly, just very quickly, although it is the separate field in drilling, we have we call this conductor and we drill the well. So in this field, the terminology is called wellhead and Christmas tree. They are the equipment to maintain surface control of the flow of fluids from the well. A wellhead provides a safe and adequate means for supporting and attaching the blowout control equipment during drilling, and later it provides sealing between casing strings and a connection for the Christmas tree. Just for information, the reservoir is at very high pressure. So we have to hold the pressure with this wellhead equipments. Wellhead varies in size, strength. When I say strength, it means pressure rating of the components, configuration, and depending on the well conditions. Wellhead mostly consists of several very heavy duty fittings and with certain part designed to hold very high pressure. Just imagine the whole reservoir pressure is controlled by this piece of equipment, which is very rigid and very high pressure rated. If you see on the top, this is called a Christmas tree. Like I'm showing the cursor here. When the oil reach here on this arrow, is written here process engineer scope. The chemical engineers, which mostly we call the process design engineers or operation engineers when they reach in the field, and the professional engineers, their duties start to handle the crude oil downstream of the choke wall. So the chemical engineers scope started from downstream of the choke. Once the crude reached to the surface facilities, there is a number of surface piping and subsea piping and onshore pipeline, and number of gate valves are installed to collect the oil in the manifold and send it to the downstream process equipments. This one is the piping network. We in industry in crude oil processing industry, we have a high pressure manifold. If pressure of the oil is high, we keep that pressure separately. If the pressure of the crude oil is low, we keep it low, a separate manifold. The benefit of such segregation is we want to use the energy of the high pressure crude oil. Then for the safety reasons, we put a blow down header, a test header and shutdown valves. This is a typical configuration of the piping network on the surface. So now we have covered three areas: the well, we call wellhead, then we have Christmas tree, the third one is called piping and pipelines, plus manifold. So up till these are the first three elements of the crude oil processing in oil and gas industries. I told earlier, the first unit operation in oil processing is separation. You have to separate the different phases. In separation, we have two-phase separation and we have three-phase separation. And separation is basic principle of separation is a density difference between the different fluids. Lighter will come on the top and heavy will settle on the bottom. The separator look like this way. We have inlet stream and we receive the fluid from the well after this piping manifold and piping. And when it reaches to the separator, the gas will settle on the top of the separator. Then we have on the bottom will be water. The oil layer will go to the right-hand compartment here on this horizontal separator, and this oil will go for further processing. Just keep a note on this one. There's a very thin layer between the black layer and the blue layer. This is called emulsion. The real challenge of oil processing is to get rid of emulsion. Free gas is easily handled, free water we can handle, free oil we can handle, but emulsion is oil is mixed with water and we have to break the emulsion to get the oil from that layer. Now, in oil industry, as I told earlier, we have oil, water and gas. So free water is a water which is readily separatable. So we use the gravity type separator to get rid of the free water. So there are two types of water now. One is called free water, other is called emulsified water. So a free water you can put on any vessel, and in this vessel, the free water will settle on the bottom and you can treat the water separately. We are planning to make a separate session sometime later on how to handle the water in the oil and gas industry. That itself is a separate topic which need a separate session, how to handle the water. As I told, the first objective is to get the free water which is readily settled in the traditional horizontal separator. There are some waters which are still remain in the oil. We have to remove that water, and that water is called emulsified water. So we have to break the emulsion and get rid of that water. So to break the emulsion, we use 4 techniques. We use the chemical to break the emulsion. We use heat to break the emulsion. We use mechanical energy, or we use settling. Settling mostly don't effective in the emulsified water. We have to use electricity so that the polarity of the electrical power will separate the water because this water is also having a salt. So the next challenge is the desalting. So I will again repeat, first you get rid of gas, then you get rid of the free water, then you get the dissolved water in the form of emulsion. And the 4th unit operation is called desalting. So the crude is having salt in the crude oil. Refineries do not accept a crude oil with a heavy amount of salt. They want a crude oil which is free from gas, free from water, and free from salt. So desalting operation is a reasonably sized in oil and gas industry. we have to wash the crude. When you say desalting, simply we have to wash the crude with good quality water. So salt will go into the water and then the crude will be having less salt contents. When I say washing the crude, you need a good quality water. You will supply the water with the pumps. You mix this water with the crude oil. This water which we are sending to wash the crude should be free from oxygen. So we have a plant we called desalting feed water. We get rid of oxygen from the natural water. We put oxygen scavenger or oxygen stripping tower. So the water which we are supplying to wash the crude should be free from oxygen. Once this water is free from oxygen, we store this water in storage tank, and from the pump, we send the water to the desalter. As a pictorial is here, this is a typical flow diagram of desalting and dehydration in any oil and gas industry. Major, I will repeat, the major is get rid of free water, get rid of emulsified water, and then put the clean water to wash the crude and get rid of the salt. So these are the three major steps to make the crude ready for sale. Now, emulsion, as I told, this is the biggest challenge in oil and gas industry to get rid of emulsion. You know, when you have a gravity separator, the oil is lighter, water is the heaviest, gas is the lightest. It will be very quick separation. But emulsion is in between oil and water. So I will just let you know the brief about the emulsion handling. We need specialized treating for breaking the emulsion. Emulsion actually consists of water drops suspended in the oil solution. Or you can say oil in water emulsion consists of oil drops suspended in the water. Both way, these are not separatable by gravity. Simple gravity will not help to separate the emulsion. So this is a very good indication. You see here, we have on the left side, we have water drops and oil is trapped. And on the middle one, oil in water emulsion, oil is all around and water is in between. This center emulsion is very valuable. We have a lot of oil, but in the oil there is a water trapped and we want to get rid of that water. The third one on the right hand side is a clear water which you can call as a free water. So water is settled on the bottom and oil is on the top. Emulsifying agent, why, you can ask a question, why we have emulsions? The reason is we have some impurities coming from the rock, from the subsurface, which is asphaltene, we have resins, we have paraffins, and we have oil-soluble organic acids. These all impurities help to make the emulsion. So these are called emulsifying agent. How to demulsify? We have a demulsifiers. So this is called demulsifier. I will go back. This is emulsifying agent, which is the 4 items, and these are demulsifier. So when this oil and water molecules have attraction to each other, they make emulsion. The second process which they attract each other is called flocculation in the process industry. The third one is called coalescing, and fourth one is called solid wetting. So these are the 4 thermodynamic principles which will make the emulsions tight. So now the first one is you give a settling time in a big vessel. So whatever water can settle on the bottom, you will take that water out from the system. But still the water emulsion is in between oil and water and it will not settle by gravity. So for that one, we will provide the heat. Very simple. You will put the heater, or you will put the oil in the heat. We call it heater treater. The diagram on the right hand side is a typical heater treater. We heat the crude oil. The moment you heat the crude oil, emulsion will break. Okay, and we can also add chemicals. So the water will become free water, settle on the bottom of the heater treater, gas will be escaped and oil will be treated in the middle. So heat actually speed up the action of the chemicals, and chemicals make the film of emulsifying agent around water droplets rigid. When heat is applied, the water droplets expand and break the film which is on the top of the water. So droplets then merge together, making a big drop and settle on the bottom. In process, the brief is you apply the heat to the crude oil to break the emulsion. The second technique which we are using in industry is adding the chemicals. Just for your information, this powder, the laundry powder, surf or any powder, this is one of the chemical to break the emulsion. You know, when you have the laundry, this oil, the detergent, it will take the oily portions or oily parts from the cloths to break the emulsion and put in the water. Same principle we are using in this oil industry. We put chemicals. The chemicals, they react the film around the water droplets. They will destroy or neutralize the film, thereby allowing the waters to coalesce, make the bigger drop and settle. So the first technique is the heat. First is settling, gravity settling. Second is called heating. Third is called chemical. So these are the third technique to break the emulsion. Another technique which we are using in industry is doing two objective. You know, this water is a salty water which has positive ion and negative ions. So we use electricity. So when the ions are moving, they will move in the water phase. So the water will be separated along with the salt. This vessel in the oil industry is called electrostatic treater. So the first one is called heater treater. Second one is called chemical injection skid, where we put the chemical. The third one is called electrostatic treater. You applied electricity, there is a negative electrode, there is a positive electrode. Water along with the salt will rush to the negative ions and positive ions, and in that attempt, the crude get rid of the water and salt. Now, once you get rid of water, gas, emulsions, the crude is ready to be stored in the storage tanks. The storage tank in oil and gas industry, this industry is mostly located remotely and not very near to the destination of the refinery. Storage tanks plays a major part. I give you one example. If we do not have enough storage capacity, and if the shipping is not available, you have to stop the production from all the wells because you cannot store the oil. So storage tanks are very major, looks like very simple unit operation, but it plays a big role in achieving smooth continuous operation of the oil processing facility. And it is very expensive option to store huge crude oil. They are actually, there are 2 or 3 types of storage tanks. Sometimes they are stored as a intermediate storage tanks. Then we have a big storage tank and the booster pumps. And then these pumps take the feed from the storage tank and either send to the cross-country pipeline or the subsea pipeline to the shipping area. When you reach to the shipping area, then we put another tank called terminal form tanks. Like in the port, we have a lot of tank form areas. So crude oil is coming from different fields and stored wherever the seaport is available. So there are 3 types of storage tanks from the duty point of view. Intermediate tanks, then we have a main storage tank in the area which is producing oil, offshore or onshore, and then you have the tank farm area which will store the huge oil very near to the sales point going to the different consumers. There are 2 types of storage tanks. Okay, as you know, the oil is coming with hydrocarbon gas. We want to sell the crude oil which has no salt no water, and no gas. All these processing facilities which I have explained, it will help to remove the water, gas, and oil, but still there are some dissolved gases. When we sell the oil to the refinery, they took the oil in the tanker or in the pipeline or in the ships. The requirement is crude oil should be stabilized. It should not have the vapors while it is being transported from one location to other. So we stabilize the crude, and in industry they call reed vapor pressure, RVP. So in the range of about 9 to 11 or 9 to 12 is the normal industry standard to sell the crude to the customers. Now, when you send the crude oil to the tank, still it has some vapors, and we want to get rid of that vapors. And we use floating roof tanks, which has breathing valves on the top. So whatever gas is left in the crude oil, it will be vented on the top of the storage tank. These are very expensive equipments. Just for your information, one storage tank of 1 million barrel capacity costing about $400 million. It's a very expensive equipment. Then the second, once the crude oil is stored, this is the overall pictorial which I have briefed previously, that crude oil will be treated in the facilities. This one is the processing facilities. Then we send it the crude oil storage tank. You see how many storage tanks are there? The reason we are putting a lot of storage tank, because if we are unable to sell the crude oil because of the rough sea or because of the problem, we have to stop the production. And we do not want to stop the production because it is a revenue of the facilities. So we put a lot of storage tanks. So from this storage tank, the crude oil is going to the refineries, and from this refinery, there are finished products like kerosene oil, petrol, coal tar, and other things. So this is an overall pictorial of the whole processing facilities. Process engineers and chemical engineers mostly are involved in the second process, where we have surface facilities and dehydration, desalting. Okay, here we have to apply our skill as a process engineers for separation, for dehydration, for desalting, and also for gas processing. We will make a separate session on 2 more items. Today's session is purely focusing on oil. We have not spoke a lot about how we handle the water and how we handle the gas. That 2 areas is standalone field in oil and gas industry, how to handle the oil, how to handle the water coming from the crude oil, and how to handle the gas coming from the crude oil. Today's session is only focusing on the oil. So this is the oil train going to the facilities, and from here, the crude oil only go to the storage tank. Gas has another circuit and water has another circuit. Okay, and from this storage tank, it goes to the refinery. I will just quickly go. The water which is coming from the crude oil, we can treat with the reverse osmosis water maker to make it ready for more valuable water for use. The second is we can pressurize this water and send back to the reservoir. So we call this one produced water injection. So water is coming from the reservoir, we separate the water, we treat the water and send back to the reservoir. Just for information, although it is not the process engineering field, if we take 1 barrel of oil, we have to inject back maybe more than 1 barrel, like example is 1.5 barrel. So to keep the pressure in the reservoir, they call in terminology is called voidage factor. So if we take 1 barrel of crude oil, we have to inject like 1.5 barrels of water. So it is a very effective use of water to treat the water and send back to the reservoir. So if you see here, the water is going in the reservoir and it is sweeping the oil and then it is coming on the surface. The third use of water is to dispose the water either by disposal well or in evaporation pond. Evaporation pond is a small lake, or you can say, and then we spread the water in this lake, and with natural evaporation with sunlight, the water get evaporated, and on the bottom there is a salty layer. So these are the three uses of water, and all this water is called produced water. It's not the normal seawater. Then I will go in the end about the gas. So gas is another session, but main uses of gas is we can, in offshore remote location, we flare the gas. We burn the gas, although it is not preferred from HSC point of view and from environmental point of view. But in the remote areas where there's no alternate usage of gas, we flare. And mostly it happens in the wellhead platform. The second way is you compress the gas and send to the gas processing areas, like you compress from the field and give it to Sui Southern or any gas company. The third one is you use the fuel gas, you treat the gas and use as a fuel gas. So these are the three major uses of gas. So oil will go to the refinery. Water has three uses. Water can go to the RO plant, to the reservoir, or to the evaporation pond. And gas has three destinations. Either it will be flared, or it will be compressed and sent to the pipe gas network, or we can use this gas as a fuel gas. I think this is the last on my briefing about the crude oil processing fundamentals. And this is mainly on the oil processing. Okay. So the session is open for any questions if you have.
Yes, we have some question in the chat box, and I will read those. First, Mr. Nasser has raised the hand. I will request Mr. Nasser, we are opening your voice. Please, you can put your question to Fiaz. Nasser Ali. Nasser, you can put your question. You have raised the hand. Okay, we'll take the next question. And we have a question, Fiaz, in the chat box. And Mr. Hassan Rafiq from Pakistan. How much it costs to explore a well?
Okay, well is the most expensive element in oil and gas industry. I will give you the range. The normal cost of offshore well of reasonable depth is in the range of $15 to $25 million, one well.
Okay.
5 to 25, 15 to 20 million US dollar need to be invested in one offshore well. If you remember, about 3-4 years before, ExxonMobil was, along with ENI, was attempting to drill a well offshore Karachi. That well was very expensive, which was costing about $35 million. So depending on the sea depth and the reservoir depth, well cost is very expensive. It's a very good question. In any oil and gas production company, half of the company budget is drilling budget. Any company like Aramco, ADNOC, or where I'm working in Dragon, or any OGDC, or whichever, half of the company budget, the annual money goes to the drilling. You can imagine how expensive it is to drill the well. And on top of that, the success factor is also not known. Although you do a lot of work, but whether the well will have enough production, also there are high chances of uncertainty that you predict the production from a well, and well is not producing as per your prediction. Everything is 1 or 2 kilometers below the ground. This is uncertainty. So the answer to your question is between $15 to $25 million is the cost of a single well.
Okay, thank you. We take the next question. from Mr. Ibrar. He has raised the hand. Ibrar, yes, you can continue with your question.
Malik,
go
ahead, please.
And okay, we have Nasser Ali. Nasser Ali, if you want to have put any question, you can unmute your mic. It's
Hello?
mute now.
Yeah, go ahead, Nasser.
Nasser, you are on mute, please. Unmute your mic, Nasser.
Hello, Salam. Hello, Salam alaikum.
Walaikum
Walaikum
assalam.
assalam.
Good morning, engineer. From Nigeria here is still morning. I would like by saying good morning. I don't know the time here, there in Eastern.
Have a good day. It's all good when you are there. It's nice to see you on this webinar, and especially from Nigeria. It is a lot of time difference, and you have managed it. And please let us have your question, please.
Yes, thank you. My question is that I'm a final year student of chemical and petroleum engineering. Specifically, I'm from chemical engineering, but my colleagues, they are from petroleum engineering. I just want to know the trends of petroleum engineering in the global context. What are the opportunities that lies ahead of petroleum engineering in the future? As a chemical engineer, I see opportunities everywhere in every process industry, but I don't know about petroleum engineering because I'm not from petroleum engineering. Thank you, sir.
Okay, it's a very good for all. Oil and gas industry is called upstream industry. The name we are using is upstream industry. There's downstream is the refinery. Mostly, this is a perception in industry. It's a highly paid industry as compared to any other industry. At least in refinery, petrochemical, oil and gas production, this is the very good industry to join that one. Chemical engineers, the graduate chemical engineers, once they join oil and gas production companies, they are mostly working for the surface facilities. So their knowledge of their study, which they have done in the university, is applied 100% in the unit operation of the surface facilities. There is a very good potential in oil and gas industry for chemical engineers. They work on mostly two titles are given to the chemical engineers. One is called the process engineer. The second is called operation engineer. So operation engineers operate in the field. They operate the plant. The process engineers, they work in the office most of the time, and they provide the technical support for the operation of the plant. So there is a very big and very good potential of chemical engineers to join oil and gas production. Very stable industry.
Thank you, sir. We take next question from Mr. Jamal. Yes, Jamal, you can unmute your mic and proceed with your question.
Assalamu alaikum.
Walaikum assalam.
Janab, Mr. Muhammad Fiaz, really we enjoyed your excellent
2 hours.
Preparation of the whole process of oil from A to Z, which is really I appreciate, and you know that I'm his colleague for more than 30 years. We worked together. Mr. Muhammad Fiaz, one of the best actually I can see in this field. Mr. Fiaz, I want just to point out where the lake, you're saying, you know, the water for disposal will be in the open lake, one of the areas for disposing. Did you consider the oil contamination to the lower layers. I believe you mean that area to be very well insulated to prevent oil to sweep to the underground layers and pollute the surface water. Just if you can highlight on this.
Yeah. Okay. I agree with you. Sending the produced water to the evaporation pond is not a very preferred option of disposing the water. When we make the evaporation pond, it is like a small lake. On the bottom of that evaporation pond, we put a layer so that water will not seep into the ground. You're right that we do not want to contaminate the soil in the area. So it's a layer. A layer will be laid on the bottom of the evaporation pond so that water will not seep into the soil. On top of the evaporation pond, we also get a very thin layer of oil. We call it skimmed oil. So from time to time, we skim the oil from the evaporation pond, and we assume that the layer is intact and produced water will not contaminate the soil of that area. But this is not a preferred area, a preferred way of disposing the water. But in the remote desert area where we do not have any other way, we use this technique, but not preferred everywhere.
Thank you. We take the next question. And Engineer Mujahid, please unmute your mic and you can ask the question. Mujahid Malik.
Hello, sir. Assalamu alaikum. My name is Engineer Mujahid Hussain, and my question is related to the differences between the onshore and offshore projects, and what is the main differences between onshore and offshore in the sense of expenses, conditions, and also I would like to thank Mr. Salimullah Malik. He is one of my mentor, and I have learned a lot from him. And sir, also guide us how we can join this big, you can say, the mother of all industries, oil and gas. Also guide us, please. Thank you.
Okay. First question is about difference between onshore and offshore. Just for your information, the reservoir is deep in the rock, maybe 1 kilometer to 2 kilometer in the earth crust. So reservoir is not knowing what is on the top. This seawater in the Indian Ocean or in the Arabian Sea here in UAE or Saudi Arabia, this is maybe 30 to 50 or maybe maximum 80 meter. So this 80 meter depth of water has to do nothing with the crude oil in the rock. Just imagine, because crude oil is about 1 to 2 kilometer deep in the rock. This is from the reservoir perspective. From surface facilities perspective, that's the biggest challenge. First, we have to use the rig we call land rig for the onshore portion, and we call jack-up rig, which is for the offshore portion. So let I explain you. The most challenging is the jack-up rig. We bring a rig, we bring to the area, jack up the rig and start drilling the well. So the first, the depth of the water is just it's not a big deal for drilling. The real target is again about 1 to 2 kilometer in the reservoir. But the cost of the well cost onshore at the same depth versus offshore, maybe about 1.5 times. The example is, if we can drill the well onshore with $10 million, the same depth well will cost you about $15 million offshore. This is the first, only the well cost. Then when the crude oil will come on the surface, you have to have a subsea pipeline, and subsea pipeline is very expensive item in process industry. In onshore, you just put the onshore pipeline, which is not very expensive. So this is the difference between offshore and onshore. From reservoir point of view, no difference. The rock is very deep in the earth crust. On the surface, the cost is about, as a rule of thumb, you can say 50% more expensive than the onshore. For the second question about the job opportunities in oil and gas industry. There are opportunities in oil and gas industry. Mostly, the oil and gas industry cannot afford very fresh persons right from the university. The reason is it's a very challenging and very option. So mostly with the like minimum at least 4 to 5 years experience, they are good enough to be absorbed by oil and gas operating companies. In oil and gas, there are two types of companies. One is called operator, like Aramco, like OGDC, like ADNOC. The second is called services, like Schellenberger, like other company, like so mostly chemical engineers join with the oil production companies like Aramco and OGDC. For industry to absorb very fresh engineer from the university because of the challenges in the oil and gas industry. It's a very, it's a very risky also, especially for the offshore.
Thank you, Fiaz. One question comes in my mind that obviously they will be having a trained manpower for the oil exploration, and they will be hiring the people around the globe for these particular assignments, and how they follow the recruitment procedures. They hire the fresh engineers, train them, or what?
Okay, for about the Middle East, which I have experience of working maybe more than now. I'm not knowing about the other companies, but in this Middle East region, they are offering job to their own nationals as a first priority. And the second is there are some graduate with, especially with higher degrees, master degree and PhD, they also hire that specialized skill right from the university if the area is applicable to oil and gas production. For expatriate, they prefer experienced engineers to be recruited and start working from day one. They cannot afford the training to the expatriate engineers. So this is a limitation in oil and gas industry because the first preference to the fresh engineers is given to their own nationals. Yeah. Hello, Malik.
Hello.
Yeah, go ahead, please. Hello, Malik. I think you are mute.
Yes, Mr. Fadi, can you put your question, please? Mr. Ibrar, can you please come up with your question?
Hello?
Yes.
Yes, go ahead, Ibrar.
Okay, sir. Thank you very much for Malik Sab for arranging this event. My name is Abrar and I'm a reservoir engineer by profession. And I have a almost similar experience like Mr. Fiaz. And at the moment I'm in Pakistan. And I just wanted to compliment Mr. Fiaz's presentation. It was a nice presentation related to the chemical industry. It's just a comment, a compliment to Mr. Fiaz and to Mr. Malik for arranging such a nice event. And I just wanted to suggest to Mr. Malik that LNG is an industry which is, although half a century old, but still a lot of the petroleum engineers and chemical engineers are not very well versed of it. And I believe for the community, it will be a worth of arranging a session, orientation session for the community. And I have a good experience of this LNG industry, although my main experience is related to the reservoir engineering, but I can add a value and I can share things. So that's just an idea. Thank you very much for inviting and arranging this seminar.
Thank you very much for your compliments to Mr. Fiaz, and we appreciate that a senior professional like you are watching this program with enthusiasm. And in the opening remarks, I just added on, and I repeat it here, that you are most welcome to deliver the lectures. The problem here in Pakistan is that in our universities, we don't have knowledge dissipation. We have only bookish knowledge. No professional is contributing towards the professional grooming of the students who are passing or holding the BSc graduation degree from the engineering universities. Our aim is that the senior person should come up, they should dissipate their knowledge, they should give share their experiences so that we can motivate our engineers, local engineers. And most important thing is that we should be providing a platform for the industry-academia linkage. That will give us a benefit to our nation as well. Rasab, you have my cell phone number. We will be in touch, and whenever you are free, we can arrange a comprehensive session on LNG and the other topics which our participants are interested. If they have some expertise, they are most welcome to join us, and we will surely contribute towards our nation and the professionals who are trying to build up their future in this field. And all discipline engineers, it is not restricted to chemical engineering. We have the electrical, we have mechanical, petrochemical, all discipline of engineer, whoever want to contribute, this platform is for them. And now we take, thank you, Barsab. And now we take a question from Ziaullah. Ziaullah, please, you can raise your hand.
Assalamu alaikum, sir. This is me, Ziaullah, from Mall Island Gas Company. I'm a mechanical engineer, and currently, right now, I am at the Wellhead compression facility. My question from Mr. Fiaz Saab, that what is the main factor that affecting the well behavior? Like sometimes the well pressure is reduced, sometimes it has been increased. So what is the factor that affect their parameters?
Okay, although it's not an area, but we have some understanding about well. You know, well is it is a preferred that well should work above the bubble point. It means there should be no vapor formation in the rock, in the reservoir. This is the best ideal situation to operate the well. Most of the time, as we start producing, we deplete the pressure and the bubble point start in the reservoir. So once this happens, the fluctuation reach to the surface. Sometimes you receive a lot of gas and sometimes followed a lot of liquid. And we call this one as a slug flow, and sometimes the pressure gets depleted totally and then the pressure build up. So once the well will get old with the production, we start receiving the slugging flow in the well. The problem, this type of wells, has to handle on the surface by surface facilities engineers like yourself and other engineers on the plant. What we do, how to handle this one, we put a slug catcher. This is like a big horizontal vessel. So we put a big vessel as the first unit operation after the Christmas tree, and we catch the slug. Slug could be total liquid followed by total gas or mixture of the two. So the answer to your question is, we have no control on the slugging flow from the well. The only thing is we have to handle the slug coming from the well as a surface facilities engineer. So slug catcher is one item. Just one very interesting, the moment you control the slug, the oil flow will stop. So this is a rule of thumb. The moment say I want to close the inlet valve downstream of the Christmas tree, the flow of oil will reduce, which we don't want to reduce the oil flow from the well. We welcome everything. We welcome gas, we welcome oil, we welcome water, we welcome salt, because this will come. Then we as a surface facilities engineers will handle the crude with slug flow. The solution to this type of variation is the putting a process equipment called slug, they call slug catcher mostly. Some vessels are working dual purpose. They are inlet separator along with slug handling. But in short, it's called slug catcher to handle the variation in the wells.
Okay, thank you. Ibrahim Sahab, you have raise the hand. Do you have any other question? Okay, Mr. Fadi, you raise the hand. Do you have any question? Or
hello, good afternoon.
Yes, sir.
Mr. Malik and Mr. Muhammad, thank you so much for a very in-depth, quiet seminar. I really enjoyed being here from the beginning. Basically, my concern is off the topic somehow, but it's actually in the topic. I'm a chemical engineer and I have been graduated last year. So I'm still haven't got an employment yet, as I've been graduated like last year. So seeking an entry position levels through my major was quite difficult for me because I have been diagnosed with an illness, or I have an accident to be exact, which left me with a partial paralysis. But I still function very well. I can walk for miles and miles. I train and I do all of that stuff. But I know it's a health and safety issue to be actually in the field, offshore, all of that stuff. I know it kind of affect the whole situation of my well-being, but at the same time, I'm quite confused. Where should I put my concerns, or where should I focus to be at? Because I really want this. I really want to continue what I have studied, and I really want to be part of the chemical engineer society in total. So how may you help me, or like actually direct me, or like just to comfort at least for the very least?
Hello, Mr. Fadi. Very sorry to come to know that you are having some medical problem. You know what? Based on our experience, we have noticed, maybe I have noticed that very few fresh engineers choose design field, like a process design engineer. I give the example of my class when we graduated in 1980. Out of 40 students, I think hardly 2 out of 40 has gone to the design field. Mostly they have gone to the cement industry, refinery, petroleum, fertilizers. I'm not knowing why fresh engineers are reluctant to become as a design engineers. For your situation, I will propose that you should focus to join a design company. You can flourish very good way to become a process design engineer. And the field is not very difficult. You have to remain familiar with the calculations and the theory what you study in the engineering. but it is a very good demanding field in the industry. The name is called process design engineers. Myself, I started my career as a process design engineer, and then I moved to the operation. So for your situation, especially with the medical point of view, you should target to become the process design engineer to join a company which design the plants. It could be Flo Daniel, it could be Bechtel, it could be Wood Group. There are many companies who are having a design engineers requirement. And if I remember correctly, even the local company in Pakistan, its name is called Descon. They also hire the fresh engineers, and they develop fresh engineers to become as a design engineers. So for you, it's better to join a design company.
Understandable. Thank you. Thank you so much for all of this.
Thank you.
And I will hopefully work on it and be in touch for further seminars. Thanks, guys.
Thank you very much all. Fiaz Saab, it was really very nice session, and more encouraging thing is the people put a lot of questions, and we have around the same time for the question and answer which you consume for the presentation. That shows how much keen our engineers are to learn and put the question, and they upgrade their knowledge. And I'm really grateful to you and looking forward to have many more presentations and training sessions from you and your colleagues. And here I will also extend my thanks to Mr. Ghulam Kafil Majal, who is the president of Society of Chemical Engineers. And I will request him to conclude this session with some comments. Kafil Saab, I will appreciate if you can acknowledge the efforts of Mr. Fiaz, and you are really a motivation for us. And we are working under your umbrella, and inshallah, this platform will serve the engineering community and the profession with the passion. Thank you all, and over to Kafil Saab. Ghulam Kafil Majal, a senior professional, and he will extend his little introduction as well. Kafil Saab, over to you, and it's all over from my side.
Thank you very much. Thank you, Fiaz Saab. It has been a pleasure. I'm in a very kind of strange situation that I am sort of in between the meetings, but I really got good time to listen to this very informative session, because the meeting luckily got postponed or delayed, actually, not postponed, but delayed. And I was very lucky to have listened to most of this. And it was really very, very informative. Fiaz Saab, I'm very highly obliged for your inputs. As you know, we were working for this session for the last so many months, and alhamdulillah, it has come to this event. And I also appreciate all the attendees and all the professionals who have put up their questions, very, very intelligent questions, very useful and relevant questions. And Fiaz Saab, thank you very much for giving such a nice presentation and following up with the answers. It's really my pleasure to be part of this community of professionals, and we will soon, inshallah, hold another event. Thank you, Malik Saab, for you are the force and locomotive, and we are all just sort of bogies, and we appreciate that. Thank you, everybody.
Thank you, sir.
Goodbye from us.
Thank you very much, Fiaz Saab, Kafil Saab, and all participants.